Hello, everybody. Today we are joining on Hangar Podcast. With us, we have Alex Eagle. For folks who don't know Hangar Podcast, this is a podcast we talk about everything related to developer experience. And Alex is a co-founder of Aspect.build and we knows everything about Bazel. He also runs a Bazel podcast, but we will be diving into the challenges of Bazel as well as the benefits of Bazel, essentially like the whole adventure and the full package. And hopefully we'll go into more technical details and we will get out at learning more about the whole world of Bazel. With that, Alex, please introduce yourself.
Yeah, thanks, Ankit. I'm really excited to be on with you. I worked at Google for a long time, 2008 to 2020. I know you were there part of that time. And I really loved having developers as my user. I sort of fell into this infrastructure, I think, a weird career path that some of us take where we just love to go down into the plumbing and we're sort of like the municipal water supply or the municipal sewer folks who are making things work. And a lot of times that's a job that not we don't get a lot of credit for doing. At Google, of course, the scale is massive and there are tons of smart people working there. I spent a lot of my time there working on Bazel, which they call Blaze internally. I was a tech lead for a couple of adjacent systems. So there's one called Sponge, which is like the results user interface that everything gets uploaded to, so you can send someone a link in your browser to whatever build failure happened so they can help you diagnose or reproduce it. And then I was also tech lead for the continuous integration system at Google, which is called TAP. I just really got super interested in working on this open source project. As soon as they open sourced Blaze as Bazel, it was I sort of couldn't help but get super involved writing the JavaScript rules for that. And I was on the Angular team at that time, and so basically found that the best way I could get more involved with Bazel was to actually leave Google and go sort of work outside the walled garden and make it work.
That's amazing. So I'm sure all the listeners are already familiar with what Bazel is, at least on the top level. Maybe we can kind of like at least do a little bit of current state of Bazel, like who owns it, what's the model of evolution of Bazel, where it is and where it's going.
Yeah, so Bazel's been around for several years. I think the first BazelCon conference was in 2017. The core project is still owned by Google. So all the development happens internally at Google, and then they synchronize the code base over to GitHub. There's a misconception that it's somehow like a different code base, and that's not really the case. They do a pretty good job of the code that they publish is the same thing that Googlers are using internally. They do a release of Blaze every week, and that's essentially the same code drop that happens as what they call the rolling releases that come out approximately weekly or so on GitHub. It's in a GitHub organization called Bazel Build, but that's essentially owned by Google. And they continue to staff the core team to make the build system work both internally and externally.
And there is like a lot of, people call it monorepo build tools almost, a category itself, which has evolved, I feel, in the last few years. Is there something which makes Bazel unique in that category?
Yeah, absolutely. I like to say Bazel's not the best build system for any language or framework, but it's the only build system for all languages and frameworks, right? Which is to say, yeah, you mentioned monorepo, and we could dive into what that means to people. Really, the attribute that brings people to try Bazel is when they have a multi-language repo. So you do normally you get started on a project and you pick a language and you go to the website and it says here's how to do builds, and you do that and you get started, and that works for quite a long time, and you reach a certain point where either the scale, or especially when you have more than one language, there's none of these sort of off-the-shelf idiomatic build systems that come with these languages are really intended to do lots of other languages. And sometimes you can kind of twist them to make it work, and in some cases these build systems are more generalized. So if you're using Make, in theory, Make can do anything. Bazel is really the sweet spot of having enough understanding of all the languages to be able to build them without you having to invent it all yourself. And yet the core engine is completely language agnostic, and it can understand, essentially, it's a dependency graph and a transformation system of taking the sources that you write and turning it into whatever the output tree is for the outputs you've requested, and it works across languages.
Very interesting. But at the same time, I've also heard from some developers, like we also did a podcast actually a few months ago with Sana, with Eric, and they kind of like also have invested heavily in Bazel, and they're probably one of the biggest Bazel shops for TypeScript. I've also heard from other folks that, especially with certain specific programming languages, Bazel could be a lot of work to manage and support. Do you think there is like depending on different programming languages, Bazel may or may not be the right choice still.
Absolutely. And in fact, I think if you have a single language and you're operating at a small to medium scale, Bazel's generally the wrong choice because it's more complicated than whatever the idiomatic build system is. And it's also just not the thing everybody else is doing, right? So you go on Stack Overflow and you have whatever random Java problem, you're going to find everybody talking about using Maven or Gradle to solve that. You have a TypeScript problem, everybody's talking about how to do that with Node scripts. And so you're always opting into this additional level of abstraction, really, right? The fact that it understands all languages is a downside if you only needed to have one.
Interesting.
Asana is a good example, actually. We've worked with Eric a little bit. And going all the way back to that first BazelCon I mentioned, I was working on the TypeScript rules, and an engineer from Asana named Mike Moriarty had done their own version of the same thing. And so we actually jointly presented the talk about how to make Bazel and TypeScript work together. There are a lot of big tech companies who have invented their own pieces. And we can talk about sort of the divergence and fragmentation of the ecosystem, but a lot of what makes Bazel successful has been pieces that folks at big tech companies have added themselves.
Interesting. That brings to kind of like, many of the audience folks here are still curious about Bazel possibly, or have heard about like enough that Bazel can solve problems, right? Like sometimes people think this is a silver bullet. But from an engineering perspective, how would they know that one, Bazel is the right approach, and two, that it's actually time to invest into Bazel?
Yeah, I think if you're happy with the build system you have, happy in terms of your ability to customize it. So often code generation is a place where customization can get tricky, right? So let's say you're using protocol buffers and somebody has to run the protocol buffer compiler to produce type signatures or client and server stubs from your service definitions. And so one way that you know that your build system's not doing everything you need it to do is that it doesn't understand how to create those, or the plugins for working with code generation are not full featured, you're hitting bugs. Another is that it's just getting slow. And so you may have a project that started out with a small number of engineers and now it has dozens of engineers. You're hitting hundreds of thousands or even millions of lines of code, and build steps are slow. Running all of the tests is slow. And now you're wondering, how do I pick only the tests I need to run rather than running all the tests every time? A lot of times you'll start off with a simple answer to those questions because it's a problem that happens slowly over time, right? So it's never, the severity is high, but the priority is always low because like this build system is not that much worse than it was last week. And so you'll see a lot of teams will adopt ad hoc solutions for some of those problems. They'll come up with heuristics about, well, if I only made changes in this folder, then I don't need to run these other tests. And they're just trying to pick some low-hanging fruit, basically buy themselves some time. And I think getting back to the question, you'll know it's time to look at a bigger scale build system when the techniques that you're using to try to buy more time are just not buying you enough time, right? So code generation is feeling hard. It's feeling too slow. And, obviously there's also other resources, your CI machine, you've been throwing more and more memory at it. And now you have to get the most expensive AWS instance to run your build because nothing else has enough RAM. Okay, clearly like you're hitting limitations.
Interesting. Are there like more objective metrics in the sense like if your build times are going, I don't know, like over 20 minutes, or if you're using specific types of build machines that maybe it's time to invest? Or it totally depends, I guess, on the code base too.
I think 20 minutes is actually a pretty good metric. I think our company does a lot of consulting, and so I do a lot of intro calls with folks who are having problems with build, and I would say 20 to 30 minutes is a common sort of low bar for where they are coming and saying our builds are just too slow. And we can talk about sort of the cognitive neuroscience behind why you need to stay in the flow and have fast builds. But anything for me, more than a couple of minutes to get sort of a fast feedback that, hey, there's a linting problem, or hey, there's like a unit test that's broken, I'm going to go off and do something else. And so you'll know that your productivity is low. Objective metrics, yeah, if you're measuring things like time to failure, time to land PRs, those are great. But I think, yeah, almost everybody has a sense of like the median or 50th percentile CI time as being something that hurts them.
Right. All right. So as an engineering manager, let's say kind of like we decided we want to invest into Bazel. Where would somebody start?
Yeah, well, Bazel does have a reputation that's historical, but also still fairly well-deserved for having a pretty steep on-ramp. I've heard it described as you need a PhD in build systems in order to get started, which I'm not satisfied with. I mean, as somebody who's devoted quite a bit of my career now to making this open source project successful, I want it to have an awesome on-ramp and for every engineer to feel like this is something I want to give it a try. And so my company Aspect provides a bunch of things. A lot of it is open source support. And one piece of that is our own CLI to wrap Bazel. So the Bazel CLI basically is identical to what they have internally at Google with like a couple of commands added, but it doesn't have a getting started flow that makes a lot of sense. So one thing you can do if you want to try Bazel is grab our CLI, the Aspect CLI, and you can run Aspect init. And that takes you through a wizard of asking which languages you want to use, and it will do some basic stuff to set up a repo that has all of the stuff in the right places. So essentially that gets you past the first step in this on-ramp, which is the boilerplate of like, okay, what files am I supposed to create? And then for the languages I've picked, how do I configure it to go find my packages and download them and give me like a place to start adding code? The second step is that Bazel wants to have a very declarative upfront configuration of what to build. It's a little bit like make files. Under Bazel, they're called build. So we refer to them as build files. Historically, you had to write those by hand. And engineers would get hired at Google. And the expectation is, well, we hired the world's smartest people, so they're willing to go learn some domain-specific language to configure the system. They're a dialect of Python. So if you know some Python, you're kind of the syntax of those files makes sense. But the idea of expressing a build graph like that is something that's kind of foreign if you're coming from most other build systems that will just infer it, or they don't need to know the dependency graph. And so the answer to how to make that easier is that the community has some great tooling. There's a library called Gazelle, or I guess I should say an application. And that thing is intended to read your source code and infer the dependency graph and then generate these build files for you. And then inside of Aspect CLI, we have that pre-built. And so you can run Aspect configure and it will generate those files for you.
Interesting.
So between init and configure, it does a lot of the work to set up Bazel for you and get you the place where you can run your first Bazel build, Bazel test, and some things will work.
Very interesting. So, okay, let's say kind of like we understand how to get started. I think one of the other things is, as an organization, there's also a need to convince the entire organization, or at least the leadership, that Bazel is worth investing into. I know that there are some people I've spoken with in the past where they tried out something kind of like for a month or two with Bazel, kind of like kicked the tires, got the builds running, but they didn't see enough value. I think probably like twofold question. One is like, how do we even quantify the value before you even start doing the work? Where it's like, okay, you know, like maybe your build times is half an hour. How do we know kind of like how far down we can bring the build times to if we were to invest into something like Bazel? And I think the second would be like, how do we even account for the amount of time or effort needed to start seeing value?
Yep. We talked to a lot of companies that are looking at this migration path. And I think, first of all, you need management who recognizes a desire for the engineering organization to be able to up-level their abilities to do things like trunk-based development, continuous delivery, improved integration testing. I think that build times by themselves is probably not enough of a reason to justify spending the amount of time it takes to do any sort of build system migration work. So there's a bunch of those facilities that are unlocked by any improvements in your build and test system, and Bazel happens to be a very capable one to do that. Determining what's the right sequencing for a migration, justifying the work, is of course a challenge. I think it's very useful to, if you're a thought leader, if you're a tech lead and part of your job is to justify why to invest in this sort of thing, I think it's a really good idea to have an exploratory phase up front, figure out a lot of risks that you can mitigate early. So, try and explore those and find things that are just not going to work. Do a small scale proof of concept that can give you some of those data points about how much faster things can be. And then, of course, like any migration work, you want to try to get as much value from it early as you can. You may never complete the long tail of a migration, and so you should be prepared for the legacy system to stay around in cases where code's not currently being maintained, and be prepared to justify during the migration project why to continue, right? So you can't have it go on forever. You also need to avoid breaking things. I like to describe this as a gradient ascent problem, that you have to change the engine while the plane's flying, right? We can't pause development work for a couple of weeks while you change the build system around. And so you also need to plan for a migration in which you have developers not being dissatisfied during the period that you're doing the migration work. And there's a lot of pieces that go into figuring that out.
Interesting. Is there a way to kind of like a mathematical way or like some sort of like way to estimate the time and effort required? Is it like, just arbitrary like 3 to 6 months to first start seeing first value out of it? Or again, it depends totally on the code base of the structure.
It's tough because there are a lot of unknown unknowns in a build system migration, because every time that you wrote a hacky shell script in the past to make some sort of a transform or execute some tests in an interesting way, and then you kind of forgot that existed, you'll have some archaeology project of figuring out what did we do that was hacky, and then we want to now do it the right way. And so the amount of time to migrate can depend a lot on how many of those sort of interesting, creative shaped things you did that you wish you hadn't done, right? For the bulk of a migration, things that are standard, you wrote code that anybody else in that language or framework would recognize as being a normal way to write that code. You just have a large volume of it. The first step in any migration to Bazel is to have the code be modular, really, because the benefit from Bazel is that it's incremental. It only needs to rebuild or retest the things that are affected by your changes. And if you have a worst case dependency graph where it's one big application, any file that changes, you have to rebuild everything, all tests depend on all code, then you can't get any benefit. So there's some amount of work in figuring out how modular things are today and how to make them more modular. You're not allowed to have cycles in Bazel's dependency graph. It needs to be an acyclic graph. I would say, trying to get back to the spirit of your question, for the most part, I think in a couple of months, you can see that your proof of concept is proving some benefits. And most of these migrations take on the order of 6 to 12 months to get, most of the way, so that like most engineers are spending most of their time doing development workflows that feel fast because they're accelerated by Bazel.
Very interesting. And I would imagine any company who's kind of like trying to adopt Bazel, that probably will be like sort of a platform team person, sort of somebody on the infra side who's owning the whole build system and the migrations. I think the question is, let's say kind of like an organization did a POC. POC was successful, at least in terms of like showing the value. How is the learning curve for the regular developers after that? Right, I understand kind of like the platform team itself will have to do a lot of heavy lifting to get to the first, let's just call it V1. But after that, what does like the maintenance look like? What does a typical onboarding for developers look like? What are some of the big gotchas there? How does that work? How does that play out?
Yeah, there's a lot of pieces to that. I would say that the ease of using the sort of all the developer workflows that you're handing to the product engineers on your team depends on how much effort the infrastructure platform or developer infrastructure team puts into making those things fit well and making them similar to what engineers are already expecting. I think it's really important to imagine sort of a net promoter score among all the product engineers who are using whatever build system migration you do, whether you're using Bazel or you're really, anytime you change developer infrastructure. Both quantitative metrics like Dora, but also qualitative things, how happy are engineers working in that repo? Ideally having a way to gather that through some sort of DevStat survey and then acting on the feedback you get. But I think your question is like, okay, sure, I'll do one of those. I already know what feedback I'm going to get about Bazel. Like how do people deal with those problems, right? So there are a few things. One of them is you don't have to force engineers to switch local development workflows necessarily. So Bazel just runs, it doesn't replace your tools, right? It's more of an orchestration layer. We didn't talk much about like sort of how it works, but it calls other compilers and test tools and whatever other things you're using. So if you do the migration in a thoughtful way where those tools stay the same, they're even the same versions, those tools are still reading the same configuration files under Bazel that they would outside. So for a lot of cases, developers can still do it the old way, right? And so when they go to CI, maybe you have CI set up that they have to make the Bazel build green. But before that, they're not necessarily forced to change. You can also tuck the Bazel build one level beneath the sort of the porcelain, I guess, to use the Git terminology of like the thing the user interacts with. So if they're using a make file or if they're used to typing npm start, or they're used to typing, whatever command that they use to interact with the system, you can often leave that in place, just have Bazel fetched, and some of those workflows will now invoke Bazel, but you don't necessarily need to retrain developers.
Interesting.
I mentioned build file generation already. That's one of the most important things to do to make it so that developers don't have to fight with this tool. Like 80% of the time for 50% of the languages today, at least, you should expect that the tooling just automatically updates the Bazel configuration. And that's an area that we're pushing a lot on to make it more like 90% of the time for 90% of the languages, you just expect that those things can be automatically generated. And then at the risk of giving a super long answer, I think there's also editors is a place that we see a lot of pushback from Bazel because Bazel will put things in a place the editor doesn't expect. Essentially, because of its legacy within Google, Bazel is allergic to having any of its outputs live in the source tree. And Google has this version control system that's like a Perforce clone called Piper that doesn't even have a concept of git ignore, right? There's no way to have things live in the source tree and not check them in. I think that's somewhat of an accident. And so part of the answer for editors is we actually can tell Bazel to put things in the source tree. It's just a little bit unnatural because you need a combination of a check that says that the source copy is up to date with what Bazel would generate, and then a command that's essentially like a fix-up command that brings those generated outputs and puts them back in the source tree. And if you follow that, I think for the most part, you can make editors happy by sort of repairing the ways in which Bazel is weird, by putting things back in the place where they're expected.
Interesting. So when this platform team is actually like educating developers about using Bazel, are there certain specific things that they need to emphasize on? So for instance, like, are there new type of build failures or like, compile errors that they will now need to get familiar with? Or like kind of like thinking about like, when you talk about modularity, at what level, at what granularity should we define build files? Stuff like that.
Yep, those are both things that happen. So error messages, yeah, Bazel will sometimes report something that you would never have seen before. Bazel has pretty bad error messaging, I think. It's another area that we're excited to work on. We've spent some time in our CLI, and it's certainly possible to do this in your own tooling to try to intercept error messages and improve them with links to your internal documentation that give people a better idea of what to do. I love writing documentation. I think people often don't read it. And so I think it's a really important technique to try to put the documentation in the place the developer would have come across it already. Let's see. So the other half of this is...
I think one part maybe I'm kind of like I can double click on a little bit more is we talked about like whole dependency mesh, dependency entanglement, as I would like to say it, right? I know there are definitely certain organizations who have adopted Bazel, but their dependency graph is a mess, which essentially means at any given time you're still pretty much running everything or like building everything at every file touch. Are there any, I know this is kind of like also just more software engineering common practices, but like are there some recommendations within Bazel to improve modularity?
Yeah, I actually had a customer this morning asking about that because like PyTorch is this gigantic this thing, and if you have a model class in Python that's in the same package with some service code, then anybody who depends on your model now accidentally has a transitive dependency on PyTorch, even if they're not trying to do any AI training or inference with your model class. Right, and that's a specific case of, like you say, this is just general software engineering principles of trying to have things be layered, follow design patterns like, MVC or model view presenter. We've always, engineers have always been fighting with this tendency to put everything together in a clump, and then like that makes it hard to maintain. And in the case of Bazel or any other tooling that's dependency graph aware, it also means the dependency graph doesn't allow for incremental builds because everything is connected. Another good example is a Bazel anti-pattern that product engineers could run across, and this answers your previous question about how to train them also. You could easily write a file that imports from every single one of your libraries, and then your tests you could have depending on this file, and now that's going to be sort of an inflection point in the dependency graph that causes any change to affect all tests. You could even in Bazel you can write Bazel extension code, which has load statements. You could load from every different language ecosystem at the top of a file because you just want to provide a lot of convenient defaults. And now anytime you anytime you reference that file, Bazel is going to want to eagerly evaluate all the load statements, and you're going to download a Rust compiler and a Go SDK and all kinds of unrelated stuff and make engineers unhappy. So yeah, that's definitely just a part of software engineering that we already knew, but it makes Bazel a lot harder to get good performance from it.
Interesting. And what's kind of like the ongoing maintenance cost like? I mean, once somebody has adopted Bazel, sure, it is a little bit more modular now, kind of like things are, compiling well, we're able to scale well. What's an ongoing maintenance of Bazel look like? Is it like you don't need to worry about it anymore? Like product engineers can handle it, or do platform teams still need to be involved on a regular basis for some maintenance?
My experience has been that there are a lot of teams where they had somebody like an ex-Googler especially came in and like said, "Hey, Bazel's great," and convinced them to use it, and they put it in place. Everybody's been using it for several years since then, and everything is pinned on old versions. And Bazel's very reproducible, and usually the way it's set up with each language package manager is also like pinned requirements or npm dependencies or in the case of Maven and Gradle there was never really a lock file, but Bazel has invented one. So for the most part, if you check out code from 3 years ago and you type Bazel build, it still works, right? In almost all cases, to the extent that it was hermetic, right? If Bazel was managing all the dependencies, obviously, if you're allowing it to go find things on the machine and you had a special setup 3 years ago, then it's not going to still work. So that means part of the answer is if you're okay with keeping things on old versions, then Bazel can be a very small amount of maintenance headache. So you're just continuing to add product code, you're adding new build files, but the build files you're adding look similar to the ones you had before. Maybe they're automatically generated with Gazelle, or maybe there's copy paste, and for the most part, that's enough. So I think the place that maintenance really shows up is in two cases. One is, oh, and now I want to do something totally different. I'm going to add a new language. I want to add a new code generation technique. And none of the stuff that I've set up before handles this. And so I need to learn some more Bazel. And then the other one is if you want to keep up with the latest releases, Bazel 8 just came out this week, I think, and it has a pretty big change to how you declare your external dependencies. They're in a multi-year process of moving from this workspace file that was like kind of poorly designed and didn't have any understanding of transitive dependencies to a module system that's much better. But for most users, like that migration is work. Anytime you update any list of dependencies, there's migration work. And so I think the other part is just keeping up with the latest. There's some churn there, and that's where I think teams need to prepare to continue staffing their dev infra team to periodically keep stuff up to date.
Interesting. And are these new Bazel versions generally backward compatible?
Generally, Bazel has far too many flags. And a bunch of those flags start with incompatible something or other. And those are usually, like that naming convention suggests, okay, there's a breaking change coming. For the most part, the breaking change doesn't come in a single version of Bazel. So you'll have a flag that you can still turn back off again to get back to the old behavior. So that's nice. It allows you to decouple the actual Bazel version upgrade itself from the chore of accounting for the breaking changes and essentially like opting into the incompatible flags. And you can do those in either order. For the most part, those flags are also present in the previous version of Bazel. So you could make your stuff stricter, turn on some of those flags, make your code base compatible with it, and then you can upgrade to the new version. I do think there's a lot of the challenge comes from how Bazel has a dependency graph that includes transitive dependencies. And so like there are a lot of languages where you get your library dependencies as source code. C++, Go, really anything that compiles to machine code is kind of like usually delivered as source code. So the flags that you pick may also affect the third-party libraries that you need to build. And those third-party libraries may use Bazel rules, which is to say like plugins for different languages that are compatible with different sets of flags. And so a lot of it is sort of jiggling versions and figuring out what order can I upgrade things so that everything that I depend on is compatible with the new versions.
Interesting. Maybe one last question we can try to cover is, and then we can try to summarize. So let's say people are like using Bazel properly, have adopted it. Is there a way to think about like health of Bazel system? Is this kind of like, for instance, I think probably a big part of this would be understanding the dependency graph itself. Is there sort of like a way to measure ongoing progress or like evolution of internal dependency graph or build systems, or like understanding like, are we keeping these things in checks? Are we kind of like scaling ourselves well? Is there a way to kind of like...
Bazel has a lot of facilities for you to inspect what's going on. And so, for example, it has an entire query language that allows you to query that dependency graph with a lot of power and expressiveness. You can even write little programs that are executed over the graph. So if you know what question to ask, then you can definitely understand what's happening. But I think your question is more like, what kind of dashboard could I set up that says the build system is working great? Even at Google, I don't think we had a great answer for this. I think there was, obviously, there are certain top line metrics, things that you would see even showing up if you did a Dora report, things like how long it takes to land changes, how long it takes for a first-time engineer to get up and running. And those things indirectly capture how well the build system is performing. But of course, there are other factors that go into those. So I think it's difficult. And you know, like the build will naturally become longer as engineers are making changes that cause tests to run, and they write tests that take a long time to run. You have more and more integration tests that bring up a full stack, and like you're expecting that that's going to take time to run. So I wouldn't say that you can simply measure, like, is test time staying constant over time? That's not something that we're expecting to happen.
Right.
Right. And so really the question is, how well are we doing compared to how well we could be doing?
Right.
And that's pretty hard to say.
Yeah. I mean, maybe one thing we can kind of like start looking at is like how often are we hitting cache misses, or like kind of like how much of the graph are we actually building every time?
Yes.
Because at least that can give you a perspective of how well are your dependency and modularity of the code.
Yes. I think overall the cache hit rate. So we didn't talk about Bazel's architecture, but essentially you can plug in a distributed cache that understands these intermediate build artifacts to prevent rebuilds. And that cache should have a 95 or something % cache hit rate. It's definitely the case that if the cache hits go down sharply, then you've probably got a determinism error somewhere in the graph, which is to say like some build step is producing a timestamp, and so anything downstream of that, now it gets invalidated all the time. That's an obvious health degradation to go fix.
Nice.
Broadly speaking, it's hard to say, like, as developers are making changes, whether, like, how incremental should a given build be, right? I change a comment in a test in my Go code. I'm not expecting to have to rerun all the other tests, clearly. If I change the version of the Go SDK, I am expecting to have a very non-incremental sort of build the world.
Right.
So one technique that can help is actually setting up a periodic build that happens twice at the same version control snapshot, maybe on 2 different machines. So you know that there's not any code changes between the two. Now you do expect one to be 100% cache hit based on the other. And if that's not the case, so it's tricky to set up. There are ways of capturing some of the intended outputs. I guess I would say the other part is simply, as engineers are using the system, give them an easy way to complain about a build that feels slow, or an easy way to complain like, hey, I downloaded a Rust compiler and all I was doing was a Python change. And it's not really satisfying. Like, I think you and I would both rather have dashboards and metrics that drive us to those things. But at least being responsive to users is a table stakes.
Nice. Yeah. Okay. So just to summarize, Bazel isn't really for anyone, like especially kind of like some of the signs are if your build times are increasing or if you're using multiple languages and you're looking for kind of like a more standardized way of managing builds and scaling your engineering org, that would be a good place. And obviously it would take at least like a couple of months for you to start seeing value and kind of like really understanding how much impact it's going to have would require like doing some proof of concepts and some evaluation. And yes, don't take it lightly. It is definitely a long road, but it does pay off, especially as your engineering team scales.
Yep. I think maybe one thing I would add is that teams that do successful Bazel migrations are generally doing it because they have made a commitment to scale, which is to say either they're planning to bring on a lot of new engineers and want them to be productive. They're planning to add a lot of code and want to continue to be able to do trunk-based development. And so they understand essentially that infrastructure for engineers is a competitive advantage that they have over other companies. And so they're making a conscious decision to invest. Right? And I think the flip side of that is engineers, especially, they come out of Google and they go somewhere else and they're like, hey, Bazel is correct, and correct is what everything should be correct. And so let's do that. There's, engineering is always trade-offs. It's pretty important to have enough backing, enough like thought put into the benefits that you're expecting to get from a system like that to do the investment and to justify the investment over time.
So in a way, kind of like also providing more standardization, and which helps with like some of this justification too.
Yeah. What do you mean by standardization?
Like for instance, like engineers coming from Google, like they already are familiar with like Bazel in some ways, and like if you use Bazel, you can also use it across all your different programming languages. Which essentially means now there's like more standard ways for developers to operate, and could also improve like developer experience that way. Except there is a bit of a learning curve. Yes.
No, actually, you raise a point that I totally missed and should have included, which is that if you want to have full stack engineers, or you want developers on one project to be able to go edit some library they depend on, or be able to go change the front end because they're adding a feature that requires that, then standardization across how you do build and test in your entire organization means that developers can just parachute in anywhere and they're instantly able to build and test and make changes. Yeah, that's important too.
Cool. All right, Alex, I know we already went over time. So thank you so much for this amazing conversation. And for the listeners, hopefully you learned a little bit more about Bazel. Yeah, that's all for now. So have a great weekend, Alex, and enjoy your holidays.
Yeah, thanks a lot, Ankit. You too. Happy holidays.
Bye bye.